Graph the following rational function by finding the horizontal and vertical asymptotes and the x and y intercepts. The function is g of x equals x over x squared minus 9. In order to find the vertical asymptotes, simply set the denominator equal to 0 and solve for x. This denominator factors into x plus 3 times x minus 3 by difference of squares factoring. And then we can set each of these factors equal to 0 to solve for x and see that x equals negative 3 and x equals positive 3. Those are the vertical asymptotes for this function. The horizontal asymptote for this function depends on the degrees. So the degree of the numerator is 1, and the degree of the denominator is 2. And since the degree on the denominator is bigger, I call this bottom heavy. And that means we will have a horizontal asymptote of y equals 0. The third thing that needs to be found is the X Intercept. And the X Intercept happens when the numerator equals 0. And when the numerator gets set to 0, you will need to solve for x. And in this case, it's already done. X equals 0. So that means the x-intercept for this function is 0, 0. Lastly, we need to find the y-intercept. Y-intercept. And with the y-intercept, evaluate the function at 0. So it will be 0 over 0 squared minus 9, which is 0 over negative 9, which is 0. So the y-intercept, we have an input of 0, and there's an output of 0. There is the y-intercept for this rational function. From the previous slide, all of the pertinent information is here, the vertical and horizontal asymptotes and the x and y intercepts. And on the graph, the vertical asymptotes, the horizontal asymptote, and the x and y intercept are already graphed. When graphing this function, we need to look to the left of this vertical asymptote and figure out whether the graph will be above or below the horizontal asymptote. In order to do that, we pick any number you like to the left of that vertical asymptote and evaluate the original function at that x value. So I will choose negative 5, and that means we will have negative 5 over negative 5 squared minus 9. And when you use your order of operations and simplify this down, the result is negative 5 over 16. So the input is negative 5, the output is negative 5 over 16, which means when we look back at the graph, this ordered pair tells us to go left 5 and down a little bit, about right there. So what this ordered pair tells us is that when we are left of this vertical asymptote, the graph will be beneath the horizontal asymptote. So in order to draw that in, it's going to look something like this. Now, when we get over here into the middle section between this vertical asymptote and this vertical asymptote, we need to figure out if the graph will be above the horizontal asymptote or below the horizontal asymptote. The twist in this problem is that we have an x and a y intercept that lies directly on a horizontal asymptote. What that means is we have to treat it like a third vertical asymptote. So we need to pick a value that is between -3 and 0 to see if it'll be above or below the horizontal asymptote. Then we will need to pick a value between 0 and +3 to see if the graph will be above or below the horizontal asymptote. So anytime we have an x-intercept on the horizontal asymptote, we will have to check both sides of the x-intercept. And when you do that, say you substitute in -1. So down here we'll do some work. G of -1 equals -1 over -1 squared minus 9. And when it gets simplified down, that becomes -1 over -8, which is 1 over 8. So the ordered pair is our input, -1, paired up with our output, 1 over 8. That means when we go left 1, the positive 1/8 tells us to go up just a little bit. Maybe right there. What that tells us is if the graph is between this vertical asymptote and this x-intercept, it will be above the horizontal asymptote. So it'll look something like this. And we know that we have to touch that x-intercept, so I drew the graph all the way over to the x-intercept. And if you come back over here and do a couple more calculations like these, with, say, g of 1 and g of 5, to figure out what is going on between the x-intercept and this vertical asymptote, and then g equals 5 to figure out what's going on to the right of this vertical asymptote. And you get something like this. When you substitute in the 1, you get -1/8. And when you substitute in the 5, you get +5 over 16. That shows you that the graph will look something like this. And this is the graph of the function g of x equals x over x squared minus 9.